So next important one, Hive partition table. Initially I explained Hive has different types of tables, right? Hive has different types of tables. First one, managed or and external tables, right? External tables, managed and external tables. Next one, partitioned, partition and non-partitioned tables or non-partitioned tables, non-partitioned tables, non-partitioned tables. Next one, bucketed and non-bucketed tables, bucketed and non-bucketed tables, non-bucketed tables. So here default is managed. So we have, instead of R, let's take and. Two types, right? We have two types. R means only one. So we have managed and external tables, partitioned and non-partitioned tables, bucketed and non-bucketed tables. In partitioned, default is, in partitioned and non-partitioned, default type is non-partitioned. And default one here is non-bucketed. Default type is non-bucketed. Non-bucketed. Bucketed. So default type is non-bucketed in bucketed and non-bucketed tables. In partition and non-partition, default one is non-partitioned. Why partition? So first of all, what is partition? What is partition? Breaking one table into multiple tables. Okay. In a table, we want to divide the data into multiple parts. Dividing table into multiple tables is normalization concept. So we applied a normalization to eliminate duplicates, right? But here, why we came for partition is, first, why partition we'll discuss. Then next we'll discuss what is partition. So partition is to improve performance of query. Performance of query. To improve performance of query. Because joins taking multiple comparisons. Taking multiple comparisons. Multiple comparisons. Multiple comparisons. To avoid these multiple comparisons, we are going for partitioning. We are dividing table into multiple table only, but instead of comparison, to reduce number of comparisons, simply we can say to reduce number of comparisons. Number of comparisons. To reduce number of comparisons. to reduce number of comparisons. To reduce number of comparisons. Not about giants. Let's take equigiant. Yes, equigiant. Equigiant takes multiple comparisons. To reduce number of comparisons, we are using partitions. Example, let's take sales data. So we have assume total how many states are there? 29. So 29 states. 29 states data, 29 states sales data we are storing in a single table. We are storing in a single table. Assume assume 1 year data. Assume 1 year data. 1 year data of some xyz company. xyz company. So 1 year data means assume one core records are there. One core records. Assume one core records. One core records. One core records. Requirement is find sales of uh, some Chennai. Sales of Chennai or Tamil Nadu state. So find the sales of Tamil Nadu state. So 1 year data we are applying. Only 1 year data. So we have how many records? One core records. In one core records, if you give state is Tamil Nadu, it will compare one core records with the Tamil Nadu, right? So how many comparisons? One core comparisons. After one core comparisons, assume Tamil Nadu sales just 20 records. Assume 20 records. So only 20 records are presented in one core. To retrieve these 20 records of data, we are comparing one core comparisons. One core comparisons, right? Finally, we get only 20 records. Yes or no? So to retrieve this data, we are comparing this one core. So this is 1 year data. What if you want to retrieve 10 years or 5 years data? This we are just discussing only one core records. Some companies, let's take Amazon. Amazon wants to find sales for particular state. Any state, let's take XYZ state. They have maintaining separate, for India they are maintaining separate data table. Assume India table. In this we have multiple sales data. From this they want to retrieve one state, XYZ state data of one month, just 1 month. So one day only, lot of records, right? If you take one day, some persons, like one person may order 10 items, 20 items, or 20 orders. So we cannot expect small records, right? So to compare those many records, it will take a lot of time. Then what they will do is they will apply partitioning. So if you apply this partitioning, so coming to uh, this one only. So sales partition, what we do? Statewide statewide create a separate partition. Statewide create separate partition. Separate partition. Statewide create separate partition. We have 29 states. We created 29 partitions. We created 29 partitions. Then whenever Tamil Nadu state request comes, directly we go Tamil Nadu partition and we return 20 records. How many records presented in that partition? We return that data. So in a single comparison, we are returning entire data. So earlier one core comparisons, once you did partition, it will reduce one core to one comparison. So around we reduced how many comparisons? Lot of comparisons, right? So in a single comparison we are getting data, but only one drawback is duplicate data. Duplicate data. It will create duplicate data. Okay. So partitions reduce number of comparisons. So like let me create a graphically. So yep. Let me see first. This is sales. In sales, I am creating state 1 partition, state 2 partition, state 2 partition. Like this, I am creating state n partition. So in this assume file is presented some AP, this one is TS. So like this, we have all the data. So whenever you write a query like select star from sales where state equal to AP, state equal to AP, single quote AP, then directly this one will not compare all the data. It directly goes to one comparison is state comparison. It will read all the records of this state and returns. In a single comparison, we get complete data. So like this, we separate data. Partition means we divide data into multiple partitions. We divide data into multiple partitions based on some column. So how do we divide means assume regularly this is sales data, right? We are getting queries, assume we have a complete single sales data. So this is sales table, okay. This sales table contain complete sales records, complete sales records, complete sales records. We are getting query, today we are getting query in this way. Select star from sales where state equal to some state name. So assume we are getting query in this way. That's why we created statewide partitions. Statewide partitions. Next day we are getting, after some days or next day we are getting query in this way. Select star from sales where state equal to some state name and city equal to some city name. Again we have to divide this data into multi-level partitioning. In this case it increases. So city wise we create partitions, means assume AP has some 15 or 20 states. For 20 states, 20 cities, assume 20 cities, we create partitions. Telangana has some 30 cities. We create 30 cities partitions. Like this, we divide again this one. Assume we are getting query in this way. Select start from sales where year equal to some year, some year equal to some year. Then based on year, again we create separate partitions. So this one is based on state and city. State and city, we created partition. Again we create some more partitions based on year. Based on year, we create separate partitions. So if we create separate partitions based on year, again we create separate partitions, right? So if you create partitions again, here data is available, here also same data is available. Yes or no? So here also data is available, here also data is available. These partitions related to based on year, these partitions based on state. So if you divide data in this way in RDBMS already hardware cost is high. If you divide partitions, it will data is duplicated. So then cost will be increased. And that too, one more problem is RDBMS is not unlimited. Yes or no? RDBMS is not unlimited. If you go this Hadoop side, you can divide partitions in this way in high, no issue. Because Hadoop works on normal hardware and supports unlimited storage. So Hadoop side we cannot find issues when you divide Hive partitions. But RDBMS side, if you do partitioning, this concept is borrowed from RDBMS only. RDBMS has this partition concept, but problem with RDBMS is they cannot apply partitions for all the databases. If they apply, because client to client they cannot apply. If they apply for these online shopping applications, banking applications, finance applications, then they have to buy huge hardware, but that too RDBMS cannot support unlimited. No, as a developer we create partitions. Developer creates partitions because this is part of table creations, right? Table creations. Okay, so internally Hadoop will take care to allocate memories. HDFS file system. In HDFS file system, each partition is separate folder. Each partition is a folder or directory. In that folder, this partition, each city it will create one file. Understand, right? For each year, it will create one separate file. Based on year, you are creating partition. So year it will create folder. In that year it will create, each year it will create separate file. Okay, assume you get different query, so for every query we are creating separate partitions. So to improve performance we create partitions. Okay, so it is not strict always we get data of states. We may get for year, we may get based on some products also, right? So query gets based on some products are sometimes based on some price, right? Based on some category also. So for everything we create separate partitions. If we create partitions, duplicate data. So for coming to Hadoop side, we least bother about data, duplicate data. Hadoop side, we least bother about duplicate data because Hadoop works on normal hardware. First one, Hadoop works on normal hardware. Once again, first demo class. We are revising first demo class, right? So it works on normal hardware plus unlimited. It supports unlimited storage. Then we need performance, right? So Hadoop side, we mainly concentrate on performance. If you want to performance, so for Hadoop side, we require only performance. Then we create multiple partitions. For every query criteria, we create separate partitions. But we have one problem with partitions. If we create partitions, for every partition internally, it increases name node memory space. It will create metadata in name node, right? Metadata. So metadata. So to avoid that one, we have a bucketing concept. So tomorrow class will spend to understand both partitioning and bucketing. After completing bucketing and partitioning, we'll discuss scoop. Okay. So that's it for today. Uh, Learn some concepts about what is bucketing and what is partitioning. Then we'll discuss partitioning and bucketing tomorrow. Okay.